Okay, this is a demo of how to use an RCCCv2 board to switch both 5 volt and 12 volt output. The board itself is actually meant to switch LEDs, and it will not switch the plus port, it will switch the minus port on here. That means if you connect the plus port to, let's say, my FPV cameras over there, those cameras have their ground connected to the OSD board, and the OSD board is connected to the real ground, which means just sending 5 volts to them is enough to have the ground be connected, which means it will power on. So unfortunately, the way this board switches makes it impossible to just use its output to switch things that are connected anywhere else, like FPV gear. The other issue I had is over there I have my 12 volt transmitter, different voltage obviously, and I didn't want to get into the business of converting 5 to 12 volts or the other way around. You can do it, I just didn't want the extra electronics. So the trick is to use a relay board, and that's a dual latching relay I'm using here. On the top side you can see the 12 volt connection, and on the bottom side the 5 volt. The input here is, and this 5 volt output, right? The 5 volt here is coming from the RCCC board, which itself is coming from my Pixhawks. The minus is connected to the switchboard over there. So that's the one that will either be connected or not connected. That means it's either showing ground or it will be floating. And this minus here is the real ground, and that one is actually coming from the RCCC board. I'm splicing one of the video outputs to just steal ground out of it and send ground. Okay, so basically the way it works, I'm going to use my 10Rs and send
engines armed
signal, and now you can see both cameras are turning on, and you can see the video transmitter just turned on also. I'm going to flip the switch again.
engine disabled.
There you go, and my two 5 volts cameras are shutting down. And a quick shot of the board itself. It has one diode to prevent backflow, reverse flow onto the board. It's just a protection. When you de-energize magnets, they could send electricity back, and I don't want that, especially reverse. And here I have a pull-up resistor. So the trick I mentioned is that the connection from the RCCC board can go floating. It's either ground or floating. When it's floating, you cannot control relays with that, right? So the resistor is actually meant to send 5 volts via pull-up, and if nothing is happening here, if it's floating, then the 5 volts will show up. Otherwise, this will bring ground, and it will override the resistor and energize the relay the other direction. That's the back. I mean, nothing too major. And the way the relays are connected are that when the relay flips, it also de-energizes that resistor, so it's not being powered all the time and wasting power. I'll flip it on one more time.
Engines armed.
So you can see both cameras coming on and powering on. This is probably not the most efficient design, but it works well enough for my uses. Hope this helps.